Hey guys, welcome to another episode on MSK Coding. In this episode, I'll be showing you a program I made. This program uses a Caesar Cipher to encode strings. What is a Caesar Cipher? Well, a Caesar Cipher is an algorithm used to encode words. The way it encodes is by shifting each letter some steps forward, so it becomes hard to decode if you don't know how much the original word was shifted. I printed out a Caesar Cipher wheel to show exactly what I mean. The first step of using one of these is by matching the A's together. So as you see here, both A's are on the radius here. The second step is to pick a letter. In this case, I'll be using M. So you shift M all the way up to A, making sure that everything's lined up, and then you pick a word. In this case, I'm picking cat. So since M is number 12, I'm going to be shifting by 12, which is the letter M. And so now we can start our magic. You see the C? That has O, so C is now O. A is M, so that becomes M. And T, all the way over here, is F, so T is F. And the final product is OMF. Let's put another word. How about MSK for MSK coding? And we're shifting by, let's say, 5 for the letter F. F moves all the way to A, and we start our encoding. M is R, so this turns into R. S is X, so it's R, X, and then K is P, so R, X, P. That is the real life part of this video. Let's go into the code.
We are in the program. The first line of code reads string equals input. Give the string you want to convert. That takes the input from the user and stores it in a variable called string, which is a string. Num is the exact same thing, but it is a number. Alpha is just a list with each of the letters in it. Final is another list, but it's an empty list. String gets turned into a list, and now we start with a for loop. For x in range len of string, for x in range, for y in range 26. This goes through every letter in the input of string, and then it goes through every letter in the alphabet. And if string of x is alpha of y dot upper, this just reads, if string of x is uppercase, you go to another if statement. If the number is positive, final dot append alpha y minus 26 minus stem dot upper. This dot upper will stay in this full loop. What this does is it basically strings or moves the word like it did with the cipher wheel. It checks the letters and changes them. And I put minus 26 minus num because that gets over the problem of z. If you put Z and then you put 1, it'll say list index out of range. But if you do Y minus 26 minus none, Z will roll back to A because it's cyclic. That's why the cipher wheel is a wheel. And if it's not positive, if none is not positive, you do plus, which means that you're decoding. And that means that plus is useful here. We go into the exact same loop, but just if it's not uppercase. The reason I put two separate loops is because all uppercase letters would be turned into lowercase letters, and I don't like that, so I just put two loops. They're basically the same. So this loop is pretty much the same, but now we have a final thing right here. And you do final.append alpha of y plus none, and then elif. This is the big elif statement, because if this is not a letter, if it is a other character like a space, a slash, quotation marks, or anything else, it just goes into this loop and it appends it to a string of x. So it doesn't do anything fancy because there's no uppercase version of just a symbol. But final is nothing dot join final, which just joins the list together into a string, and then it prints it. Let's run the program now. So the first string, let's put cat, or let's show off the uppercase, so we'll put cat, and on the cipher wheel, M was 12, so put in 12. It becomes OMF. That is exactly what the cipher wheel outputted. Now, if we put MSK, and I put 5 for E, or F, it's RXP. And again, that's what the cipher wheel outputted. We can show off the symbols by putting MSK, maybe a colon, a space, a slash, and coding. And then we put, let's say, I don't know, 1. It becomes LTL, and the symbols are exactly the same, DPEJOH. So that is the examples done. That is the video done. I hope you like this. Bye!